My name is Patrick Cooley, and this is Mike McCabe. We're from nVisium. We're going to talk a little bit about Docker and some automated security using Docker containers. Anyone here familiar with Docker or with Linux containers in general? A couple people back there? Okay. All right, a few people, good. I talked to some people during the conference on Friday and also yesterday, and everyone I talked to seemed to not even know what Docker was. So it's good to know a few people in here actually have at least heard of it. What's that? All right, so this is Dr. Docker, Building Your Infrastructure's Immune System. This is kind of a work in progress. We're still, there's still a lot of things that we're trying to get right with it, but it's a good start. So I'm going to start talking a little bit about what Docker is, and then we'll get into some more of the interesting stuff. According to Docker's website, this is kind of their understanding of Docker, which doesn't really help for me at least. I mean, an open platform, distributed applications doesn't really explain a whole lot. So we decided to go over to Wikipedia and see what they have to say. And it's a little easier to understand. There's Jimmy asking for some money since we went there. Anyway, what is Docker? It's lightweight systems, allows really fast deployments. You can take what was done with containers for years and years and years, but now you can sit down and version them. You can deploy them across different places. You can reuse parts of the images inside the containers, so all your containers don't have its own image. There's a lot of different things. It makes development a lot easier. Your development environment, your QA development environment, your production environment are pretty much exactly the same. You don't have to worry about, tweaking something here or there, and your QA guy doesn't have some driver or something installed or some small little library missing. So let's take a look at a little bit at virtual machines. Every time people think of Docker, they kind of always ask, well, what's the difference between that and a virtual machine today? And this is a pretty good image. Virtual machines have some pluses and they have some minuses. Same thing with containers and using Docker. As you can see here, pretty much the biggest thing, a virtual machine has an entire operating system for every single machine, which causes some issues. It's a little slower. It doesn't have as, it's got a lot more bulk to it, but it separates everything a little bit better. One of the biggest issues right now with Docker and containers is because everything's built on top of a single host, there are problems with containers breaking out of their container and getting access to the root, to the host system, or getting access to other containers that they shouldn't have access to. So this is a little bit how an image works. You pretty much start with the underlying system, and then you start building up images in different layers. So you can have a Docker container that's built, its image might have a different starting image. Like you might have your base Ubuntu images, and all your Ubuntu Docker containers will start off with that same base image. So you're not having to have the same image 100 times on your machine. It's once. And then you start adding the different things you want in different layers until you get to the final image layer where you run your actual container. Take a quick look about how an image is built. So this is the official repository for Ruby on Rails, and as you can see, this from part shows that this is not started off with its own image. It's actually starting from the Ruby image. Specifically the latest 2.1.3 image. And then from there, Rails decided to start adding some more stuff. So as you can see, we created a directory inside the image for our application to run in, and then started adding in the gem files, set up bundler, so as soon as you start up this, you build this image, first thing it's going to do is download all the gems with bundler, and it's going to stick it into a layer. So now if I start tweaking this a little bit and add some new things towards the bottom, because of the way cache works and the different layers on the image, I don't have to worry about going down and downloading every single time all these Ruby gems. Only if I mess with the gem file or I mess with these particular on-build lines will it require me to go back and re-download those and recreate that particular image layer. A couple other things going on here is we're pulling down some stuff from apt-get. As you can see, Node.js. Expose 3000 means that we're telling the container that when it runs to allow Docker to access port 3000. This does not give access to the root host with expose. There's more commands you have to do, but you can't, if you don't expose it to Docker, Docker can't expose it to the root, to the host system when you need to do that later on. And finally, Docker is designed to run pretty much one process. That's the whole goal. People try to get away and add a bunch of different things going on at once, but the goal is run a single process for a single container. If you have an application like we'll show you a little later where there's database components, then the database components run in their own layers or their own containers. So that way, if I'm messing with the web application side and not the database, I don't have to shut down the database. I don't have to mess with that. I'm only messing with the container running the website. So a lot of people keep thinking containers and Docker is designed to be secure environments, secure sandboxes. It's definitely not the case. You can try to do that a little bit, but you have to make sure that you design things properly. As you can see here, about a couple days ago, they announced these three vulnerabilities. The biggest one here, as you can see, is privilege escalation from child containers. You don't really want that if you're not trusting what's inside of your container. So the thing to know is you don't ever run anything inside of Docker that you don't fully control or you don't know what it is. There's the Docker hub where you can download images and stuff, but you should probably take a look at them and understand what's in them before you just blindly pull it down and run it, because things like this can happen, and you can't, you can't run something that you don't trust, because it's not designed to be a security tool. So I'm just going to show a quick little video of us spinning up our particular app that Mike's going to talk about in a few minutes, and just kind of show how quick you can deploy this. This app I'm going to show here, it's going to spin up 7 different containers, and it's going to do it relatively quickly. Keep in mind, this is happening a little bit faster because all the images happen to already be localized on the Vagrant box first. All we're typing is Vagrant up and no parallel command, so that way we have a couple of components like the database that needs to be running before the web tier runs. Otherwise, it won't work right. These 7 containers, we have a Nginx proxy, and that's set up so it's constantly listening for the web tier to change. If I add more containers on the web tier, I remove containers on the web tier, the Nginx proxy is going to listen, update its configuration file, and reload on the fly. So that way, you can change things on the back end all you want, and you don't have to worry about your proxy having any issues with that. And then we're doing some Elk stuff, which is Logstash and Kibana, and Elasticsearch for keeping track of logs and stuff for some of the future things we're going to do. And there's our 7 containers to start it up. We're going to load up the application here. And then also load up the web page for Kibana. And you'll see that it's already get pulled in logs from all 7 containers pretty quickly. If I typed a little faster. And there's Kibana running. There's already about 500 entries into the logs, and that's only from the first few moments that the containers have been running. Quickly talk about this, like I said earlier, this week, this past week, a lot of things have changed with Docker. First of all, those 3 vulnerabilities you saw are fixed in this latest release in 1.3, so I suggest if you're using Docker already, you should definitely upgrade. There's a couple tweaks you can do if you want to stay on 1.2 to help plug some of those holes, but for the most part, some of the benefits definitely outweigh the downsides of upgrading. So one of the biggest things that they added is Docker exec, which is actually pretty cool. It allows you to inject new commands into our already running container. So if you're running something and you need to maybe do an update or something, you don't want to pull down the container, you can do that. Typically, though, you would probably just run a new container, put all your changes in that, and then swap out the containers rather than injecting new commands into an already existing one. Docker create is kind of interesting. It gives you a little more control of starting up your containers. It's something that we saw in the API already, where you can basically provision a container before you actually run it. So now you can do that from the command line if you want to. You can do Docker create on the command line and prepare your container before you actually start it up. Some of the new security things they're adding. Now you can do custom SE Linux and AppArmor labels and profiles. Digital signatures is a big deal. Like I said before, the Docker Hub has all these images ready to go, and now that they have a lot of them are official builds from Rails or Django or any number of different systems and services. And if you just blindly download them, you don't know what's in them. So what they added now is, and they're still working on it, but they added the idea of digital signatures. So the images now have a signature. When they download, it will give you a warning right now, saying that this signature doesn't match, so there's something wrong with this image. In the future, it'll automatically stop it. It won't let you run an image unless you explicitly want it to. This helps, it helps make sure that a trusted image really is a trusted image, and that nothing's changing in between Docker Hub and your computer.
Hi, yeah, so I'm Mike, and so Patrick kind of went over what Docker is, why it's useful, and I'm going to talk about what we did with it. So we kind of chose a couple different POCs to start with, because this is all just an idea we had of how can we use something that makes deploying applications super fast, how can we use that for security. So we thought of a couple different ways. The one we'll talk about today and the one we do in the demo is securing insecure libraries. So how many people here work with Ruby or Rails? About the same amount as people who work with Docker, okay. Not our core audience today. But so Ruby and Rails, Ruby has this ecosystem called Ruby Gems. It's basically packaged libraries of code that different people write. They package it up, they put it up to this place called Ruby Gems. It's similar to apt-get or jars, Maven, that kind of thing. So the issue is that people write this code. Not everyone is that security conscious. There's a lot of security issues that come out of it. So we wanted to figure out a way to basically automatically and very quickly secure our applications against these security issues that come up. But there are some other things we've looked into how to use Docker, using it to protect against active attacks or data loss prevention. So these are kind of concepts or proof of concepts we're gonna keep building into this system, but right now we're just gonna talk about the insecure libraries. So to kind of give you an overview of how this whole thing's working, so at the bottom you have it's a typical web stack. You have RailsGoat, which is a intentionally vulnerable Rails application. It's an OWASP project. It's kind of a learning tool, but we use it as our kind of sample insecure Rails application. You have a MySQL DB, which is just the back end for RailsGoat, and Nginx proxy, which is just the web server front end. And like Patrick said, Nginx is doing load balancing, and we'll switch over to a different resource if the one it's currently using goes down or is unresponsive. Off to the right, I have to get my directions correct. We have the Elk stack, which if you guys aren't familiar with that, that's Elasticsearch, Logstash, and Kibana. So that's basically a log aggregation and searching tool. So Logstash grabs all your logs from different places. It can take like your syslog, your Rails logs, your MySQL logs, and it brings all those things together and puts it into Elasticsearch. Elasticsearch is great for searching, clearly. And so you use that to pull back certain information, and then Kibana is kind of a front end, which Patrick just showed, to do those searches. So that's what we're kind of using as our sensors in this example. So we're basically throwing all of the information into Elasticsearch and then pulling it back into the brain, which is an awesome brain image. And we're going to talk about that a little bit. But this is kind of we try to model it off of kind of a production environment of how you'd have a Rails application set up. So you'd have your Nginx web server and your Rails application in the back end and your MySQL in the back end. And then we kind of added all the custom code is in the brain, and that's what does all the magic pretty much. That's what is the glue to Docker and Rails and everything else. So like I said, what we focused on this time around is kind of securing a Ruby application when there's an insecure Ruby gem, and Ruby gems are just libraries packaged up. They're code with a little bit of metadata to kind of say what they do. There are gems that do everything. There's a gem that's the adapter for MySQL. There's a gem that does OAuth. There's gems that do pretty much everything. Rails itself is actually a gem. So when you install Rails, you're actually installing it in the gem form. And Rails itself is actually multiple gems packaged up as one gem, so it gets even more confusing. A lot of times, when we were prepping this talk, talking about containers and virtualization and gems inside of gems, we were thinking about Inception the entire time because it's pretty much what it feels like. So we use this tool called Bundler Audit. Basically what it does is checks for vulnerable versions of gems. So you have this thing called a gem file. It lists all the gems you use in your app, and then Bundler Audit reads that and looks for vulnerable versions. If you guys are from the Java world, there's a similar tool called Dependency Check. It's really useful. I suggest you use it because it will find jars that have CVEs or other public vulnerabilities. It's really useful. We all depend on a huge amount of insecure third-party software, and so these kind of tools are very useful to help you secure your applications from these issues. And third-party software, insecure third-party software is in the OWASP top 10 too, so it's a pretty big issue. And then finally, Rails goes to the app, just a sample app we used. Clearly, you wouldn't want to run a vulnerable Rails app in production, but we used this just because it already had issues built into it. So it was a good example of an app that's vulnerable and we want to make more secure. So here's sort of the demo of how everything works. So we actually have this running in a container, but for the demo, we're breaking it out of the container and just running it manually. Normally, you'd have all of these different pieces just running in their own separate containers, and then they'd all interact through Docker. In this case, just for the demo purposes, we're running it manually. So what we're going to show is Bundler Audit running first, and this is going to print out all of our vulnerable gems, and you can see there's a bunch of vulnerable gems there. And then we run the brain. Yes, it's written in Ruby. Sorry, I know no real work gets done in Ruby, but I like it. We run the brain, and this basically looks at your gem file. It finds all of the vulnerable gems. Then it starts updating your code for all of those vulnerable gems. So it subs them out and switches out the version that's fixed, and it uses Bundler Audit to tell it which ones are fixed. And then basically with Docker, it kicks off a new build, which will use those new patched versions. And we use something called, and I'll talk about this in a second, but a trusted build from Docker Hub, which basically means your code in GitHub matches your Docker build in Docker Hub. Then once that's done, it pulls down that image, creates a new container based on it, and then swaps out those two containers. So what you get pretty quickly is an insecure library becomes secure it takes about 10 minutes to run, but we shortened it up for the demo. So in about 10 minutes, you went from insecure libraries to secure libraries. And just to be correct, in production, this would run without any manual interaction of a sysadmin or a developer or anything like that. You would just have this running in the background, and it would detect issues and upgrade versions without you doing anything. Clearly, we're going to build some notifications into it because you don't want your system just upgrading things without you knowing about it, but for now, it's doing it automatically. So how does this all work? So at the core of it is the brain. Again, it's written in Ruby. Some people don't like Ruby, but you can stick with Java then, because I don't like Java. But to code in, at least. So we have the brain.rb, which has all the custom code in it that does all of the decision making. It runs all the builds. It does all the pulling down of builds. And then to kind of do those checks, we use a modified version of bundle audit. So once again, this is very Inception because bundle audit is a gem that detects other insecure gems. So it's sometimes tough to conceptualize how all this works. And then, yeah, Docker Hub has this thing called the trusted build, which is basically you sync up your code to their build system. And so that means your whatever code is in your GitHub repository is going to match that image that someone's going to pull down. And that's important because it's a whole trust, and you have to make sure that the code you can look at and actually audit that's open source matches the thing you're about to run in your system. It also has a nice feature that since we have it hooked up like that, they run the build for us. We use their infrastructure to actually run the build, which takes resources. So we use all their systems. We just have to pull the build down once it's done. And then Docker has an API built into it. It has both the client and the server kind of infrastructure that is Docker, but also has a remote API, which we use a lot of that to actually control the workings of our Docker images and containers. And that's pretty much what the brain does, is interact with that remote API. The remote API doesn't match up 100% with the client API, but it's worked well enough for us so far. And we're using this other gem called Docker-API to do all that control. And then clearly, since this is pretty new, this code has been worked on over the past 6 months, and we're continuously changing things with it. There's a lot of hacks built into it too, and there's not a lot of, I'd say it's a little fragile right now, but we're improving that as we go. So these are kind of the steps that it takes to get the work done. So one of the things that we had to figure out was how to pull a file from the container. Docker has this really odd API where instead of just being able to pull a file, it gives you a tarred up version of the file. So we had to there's some work just to pull that across an HTTP API and then pull that into the Ruby code and actually work with it and process it with bundle audit. So we pull that gem file from the running container, so we know that the versions that are running in that container are what we're actually running our checks against. And then we run bundle audit against that, and that'll give us the results of all the vulnerable gems that are in the system, and then also the fixed versions that we should be upgrading to. So that's the parse results. And then we update the gem file, which is kind of that manifest file that has all the gems, all the versions. We commit that code up to GitHub, and that's when the build really gets kicked off because, once again, Docker Hub, it's a trusted build, so any code that's in there matches the image that's on Docker Hub. So as soon as you commit that code, a build gets kicked off. And that process usually takes about 10 or so minutes. We've been working on trying to trim that down as much as possible, and it's actually mostly due to Ruby gems installs, so the more gems you have, the longer that install takes. Once that's all done, we basically have a system running that checks for the new builds and compares it to the old builds to make sure we're actually pulling down the old build, and then we swap out those containers. So all this is done, once again, once this is running, there's no manual interaction with the system at all. There's no one logging in, no one SSHing into a server, running any commands. It's all just running in the background. No human interaction needed once you boot up all those Docker containers and have it running. Well, most of your state, if you're using something like Memcache or Redis to maintain some kind of state, that would be running in its own container. You'd probably get a few cut connections if things were actually being actively processed in the web server, not the Nginx, but the actual Rails server. Since we haven't run a huge amount of volume against it yet, but it's typical for anything. If you swap out, same thing with normal deploys, if you swap out code, you're going to have a little bit of, maybe not downtime, but maybe a little bit of interruption for some people. So, I mean, most of your long-term state is kept in MySQL, so that won't change because that container doesn't get touched. But I know there are also some ways, and we haven't really experimented with it yet, but there are ways to kind of wait until all the connections are done and then initiate the swap. But right now we're just doing a straight swap. So yeah, the end result basically is we've upgraded an insecure library, and there's zero downtime. Basically, we brought up another container while the other one was running, and then as soon as that one was ready, brought the other one down. So there's no time where the application wasn't available, and there's no interaction needed from anyone, which I keep harping on, and I think it's sort of important, but I've worked in a security team where we had to do this kind of process, where you had to upgrade Ruby gems all the time. I don't know if, well, not a lot of people work with Ruby, but last year there was a big issue with Ruby gems where, well, there's a vulnerability in Rails, which basically gave you full remote code execution or SQL injection, whichever one of the worst web application vulnerabilities you wanted to do, it gave you the ability to pull off any of them. So this is actually a pretty painful point of that whole Ruby ecosystem, is upgrading these gems. So any way to automate it and make it faster and make it faster to react is, well, we wouldn't have worked on this if we didn't think it was important. So pretty important in our eyes. And since it's zero human interaction, another big thing with this project is you don't have to track anyone down who can actually make these changes. You know, you might need a developer who can actually commit code to your repository, or some kind of sysadmin to make the change. With this, you don't need to track those people down. You can react as soon as that CVE is public and in the bundler audit tool. So that's what I like about it. And again, zero downtime, which everyone needs that. So there's a lot of places we want to take this tool. It's, you know, it's sort of Docker's kind of the new hot thing in systems administration. So we figured we'd take a look at it, see, you know, how we could use it for security. A lot of people are talking about Docker and its security, you know, whether it can be used as a sandbox or whether it's insecure by default, all those kind of things. We're not looking at it from that perspective as much. Docker's one of the same things like virtual machines and every other kind of jail kind of system, that it's as secure as it's set up. So if you make it set up to be insecure, it's going to be insecure. It's not out of the box going to be a super secure system. So we don't look at it from that kind of perspective. We're looking at it, how can we use this tool that, you know, people, not everyone's using it right now, but very soon a lot more people are going to be using it. You know, Heroku uses some form of it. Google has their own custom version of containerized system that they use. Red Hat and Ubuntu, they both support Docker. A lot of more people are going to use it, so how can we use this tool that's going to be everywhere soon to kind of make security a little faster, a little less painful for security people and systems administrators, developers. So there are a lot more places we are going to take it, and we're kind of looking for ideas for other ways we can use Docker, but some of the things we want to build into it are kind of monitoring for active attacks and kind of doing active patching. That's sort of what we're already doing, but we're thinking almost at the code level versus the library level. So we have the whole elk stack built in, so we can monitor attacks that come in, and we also have a WAF spun up too that we have information to pull from. So we're kind of talking about how we can use this to do more active defense versus just patching. One of the things we also talked about was, you know, if your system is being actively compromised, using Docker just to bring it down. I mean, you could use anything for that. You don't have to use Docker, but at least with Docker you have control to, you can very quickly bring a system down. So we kind of talked about how we'd defend by doing something like bringing down the system if it was being compromised. If you saw evidence of either remote code execution or SQL injection, or someone just, you know, exporting your database out, just use the system to bring it down. But there's a lot of other possibilities for how we can use this. And we actually do have sort of a POC working for spinning up a WAF under attack. So if your application is being attacked, you can just swap in a WAF pretty quickly. And the enhancements, we also want to, you know, of course, make it a more robust system and you know, stop it from breaking as much. It's pretty new code, so it's not insanely well tested. And the other part we need to build in is kind of a testing framework for the applications, because we're basically bringing up a new version of the application without really testing it that much. So that's something we have to build in, is bringing up an extra container, running the new code, testing that, and then swapping it in. So there's some work to do there and kind of figure out other ways we can enhance this. But we kind of proved that with Docker you can very easily build a system that can defend itself against insecure code. So So to get started with this, you need a couple things. Clearly, you need Docker at the root of everything. Docker currently doesn't run on anything except for Linux, and so you can run it on OS X if you use this project called Boot to Docker. It basically uses VirtualBox and boots up a very lightweight VM that runs Docker, and then you can just basically from the command line send commands back and forth to that VM to do Docker commands. So you need VirtualBox and boot to Docker for that. And then we use Vagrant for this whole system. Vagrant basically takes all those different Docker commands and packages it up into one file and then boots everything up for you, so you don't have to do 20 different Docker commands at once. The code for all of this is up on GitHub, which is a shortened link for it. We'd love pull requests or just issues and ideas of how to improve this, or contributors if you want to contribute directly. Just talk to us and let us know. It's definitely going to be changing a lot over the next couple months. It's not close to its final form, so expect a lot of breaking changes. But it's going to just keep on. We're going to keep on changing how we kind of structure things, so it's nowhere near its final state. And then Docker Hub. So we use Docker Hub as the repository for all the Docker images. So you need an account on that. It's just where we push and pull all of our images when we change things around. And they offer free storage of images, so it's pretty useful. But basically, that's all you really need to get started, and you can have this running. Once you have VirtualBox and boot to Docker installed, you can have this running in about 15 minutes. So it's pretty lightweight. So yeah, I think that's about all we have today, but we have some time for questions if anyone has any questions.
So you see Docker being used in multi-tenant applications?
Yeah, more of that. I mean, like we said, Docker's pretty new, and so new issues are popping up left and right. It hasn't gone through a huge amount of security review, and even the kind of creators of Docker have said, like, this is not a security tool. Don't expect it to be secure. So trust whatever you're running inside of it. So yeah, a shared environment's probably not the best idea to do right now. At some point, it'll probably get to a point where it is secure enough to do that, and they're working to make it more secure, but it's more of a single tenant. I want to replicate, my environments across dev, test, staging, and production. I want what's running on the laptop of the developer to match what's in production. That's what's really useful, is that things can be one-to-one pretty much, because it's all just being, I don't want to say virtualized, but sort of virtualized from Docker. So, and also just speed, because we had someone tell us earlier today that he, on a pretty powerful system, I think it was like 30 or 60 gigs of RAM, spun up about 150 Docker containers at once with no problem at all. So, and you don't need a very powerful VM to run this. The boot to Docker runs on a pretty lightweight VM, doesn't even have that much memory, and we boot up all these pretty heavy services. I mean, MySQL's decently heavy, the Rails app isn't lightweight, and it all spins up very quickly, so, yeah.
The project started out as a closed project specifically for a multi-tenant environment. And so I'm sure they did a lot of other things on the back end to make sure that everything was safe for their tenants. But that was the whole plan, was to be a multi-tenant tool where all you have to do, kind of similar to Roku, all you have to do is just send us your image in your container, and you turn it on. And now you got Amazon Cloud, and Google, and Rackspace, all of them are accepting Docker containers. So if you have, some of them will work better with multiple containers that interact with each other like this. I'm not sure if Google or Amazon had an issue where they didn't foresee you using more than one container for any one or something. They didn't really understand the idea of single process in a container. So like, oh, you just put your entire application, your database, everything in one container. So it's not exactly ideal. But yeah, the whole idea is, and when you look at Docker's website and a lot of the other talks and dev shops about Docker, the analogy that you see all the time is, and why you see the shipping container like that is just that. It's like, I have this stuff. I want to put it somewhere. I don't care how it gets there, whether it's a plane, a ship, a truck, a train. I I just want to make sure it doesn't interact with the guy's stuff next to me. If I'm shipping bananas and he's shipping gorillas, I don't want my bananas to be gone by the time, I get my stuff. And then that's kind of the whole point of it. It's being able to move things around into multiple environments. Let's say you want to host your app in both Rackspace and Google at the same time, just for whatever reason you see fit. You can do that without having to have a specialized environment for every single deployment place. Any other questions about Docker? Or?
Okay, so as a project, and then it open source?
Yes, it started. I can't remember the name of the company. Actually, the company that started it,
.cloud.
.cloud, actually changed their name formally to Docker when they open sourced it. So they're no longer a company that does multi-tenant web applications, and now they just make Docker, and of course they sell their added services just like anyone else you're going to have or your brother.
You guys be handling other languages, like you mentioned Java earlier?
Yeah, we talked about that a little bit, and we want to make it, I mean, the goal in the end would make it just kind of plug and place. You plug in the system that you want to use to do those checks. So like I mentioned, dependency check, we could use that as long as we build a parser to parse out those results and then interact with the system. It would be relatively straightforward. I don't think there's any big technical challenges. We're just focusing on Rails right now because it's the easiest, but yeah.
I mean, once you get things a little bit better, it should be pretty easy to just add in other applications, other languages, as long as there are some of the same tools, or they have to be built that do some of the similar things in different languages. Like in this case, bundle audit. You know, we were going to be doing it in Python or something. You know, make sure there's a Python equivalent to that to do that particular piece of it.
Yeah. So, yeah, and another cool thing, which is actually kind of a big deal, is Windows is going to support Docker in the new version. I don't know what they're calling it. Like they're going to skip the 20 or
They
something
said
like
the
that.
next Windows Server version will support Docker. So, and a lot of people that were getting into Docker are like, well, it can't be real if Microsoft doesn't include it. And that's the thing. They're pushing it heavy. They're going to start actually allowing Docker images even sooner into into Microsoft's cloud. Azure. So yeah, they're going to start accepting Docker images, Docker containers on Azure as another platform. So you don't have to worry about doing things the Azure way or doing things, you know, Amazon's way. You just stick with Docker, and you'll be able to deploy anywhere you want.
Docker containers specify resource requirements like a hypervisor would require memory and
Yes, I think that's all handled. But right now, what we're using in Docker is the LXC containers underneath. I think it's all handled down there. I don't know if there's a way to change things. I think it'll just allocate resources as needed. Like I said, we've been able to run multiple containers, multiple web servers, and the application, and multiple, all those 7 containers multiple times all at the same time on this laptop. No issues. No issues at all.
Yeah.
So. Yes.
bundle update, recommended version for
It's not, so bundle, are you talking about bundle update or bundle audit? Because there's 2 different tools. Yeah. So it doesn't, it really depends on how they upgraded. If they didn't do a semantic, like new semantic version, then they'd probably just give you the breaking version. But we're using the closest next version available. So if it's 3.1.2, we'll use 3.1.3 instead of 4.0.1, for example. So we're trying to match it as close as possible to what wouldn't be breaking. That's why we need to, kind of the testing step to make sure there are no breaking changes. But generally, gems do use semantic versioning, or something pretty close to it at least. So. Yeah, no, a lot of people wouldn't do it, but that's why there needs to be a little more robust testing in this. So, oh yeah, I guess we haven't said this yet, but definitely not production ready. If we didn't make that clear enough, but please do not clone this and then run it anywhere that there's real code running. So, maybe one day it'll get there, but right now it's just kind of a proof of concept. So. Any other questions? Cool. Well, thanks a lot.